Hello and welcome. Today we're going to be talking about exponential functions. Now, exponential functions inside of Standard provide the foundation for so many topics. It's one of the most important skills that we can actually understand. So they tend to pop up everywhere, even if we don't see them. You've actually probably covered them quite a bit, whether or not you've done them in science. You may have heard about something called radioactive decay. Okay. Radioactive decay being how a particular radioactive particle will decrease really, really fast and then slow down over time. You may have also heard about things growing exponentially, such as compound interest. Okay. Or when we model bacterial infections or bacterial growth, or how a disease spreads in a population like COVID-19, for example, okay, we can actually talk about that in terms of growth as well. And what tends to happen is you have more people spreading it, okay, to other people, okay, they catch it and then they spread it to others. And then you have this exponential growth where the curve starts off quite shallow and then goes fast. So it's a really, really important skill to have. In this video, which will be one of two, okay, in this video, we're going to cover the mathematics sort of behind the exponential functions, the need to knows for us to be able to go and apply and analyze it. And then in the next video, we're going to talk about an application in terms of bushfires and what you can expect inside of a HSC question in terms of the skills that need to be asked. So where do we go and begin? You've covered up to this point linear relationships. You've covered quadratic relationships, particularly with maximum minimum problems. Okay, so now what we want to do is we want to be able to identify an exponential function. So an exponential function is really, really, really easy to identify. What you are looking for is you are looking for an unknown or an x in the power. Nowhere else, just inside of the power, okay? So if I go through and I have a little bit of a look here, you'll notice that the x is inside of the power for this particular one here, right? So it's 2 raised to the power of x. So that is an exponential function. If I then compare it with this next one, okay, noting that in the power we have a 2 and x is actually in the base, that's not an exponential. You've actually worked with these before. These are a quadratic. That's our basic parabola. So that's not an exponential function. It's not going to fit that lovely growth or decay style curve, okay? Because if you think of x squared, it kind of looks like that happy face that we talked about, okay? So again, here you'll notice that the x is in the power of the 2. It is negative. That's okay. That's just one of those areas where we talk about exponential decay, right? And I'll get on to how we know how to identify that a little bit later on. So an x is in the power. Okay, therefore, it must be an exponential curve. Okay, same thing down here. No x in the power there and no x in the power there. We do have a power of 2. Okay, so that means that that is a quadratic function. We can see because it's something squared as the highest power. Here, the x is in the denominator of a fraction, but it's not in the power of anything. You'll see that in the next, in one of the next videos that I make. That's called a hyperbola or a reciprocal function. And then we end up here with the x being in the power again. So that's the easiest way to go and identify that this would also be an exponential function. Okay, so how does this work? How do we go and sketch them in terms of what's happening? Okay, so we know we should be seeing a curve either going up really quickly or going down really quickly and then petering out. Okay, so our first function that we are going to sketch is probably the easiest to understand and is always a good place to start. So we're going to sketch y equals 2 to the power of x. Now, our easiest way to do this is with a table of values whenever we're approached with a new curve. Then we talk about interesting points that happen. So creating a table of values, depending on what you're doing, the easiest way is to include a few. So I'm going to go from -2 all the way up to 3 here, just to sort of generate a little bit of a picture. Okay, you can do more if you want, but this should generate enough of a picture for you. So what we're going to do with each of these values here, these x values, okay, we're going to substitute them into our rule up here. So first and foremost, the easiest one to go and do, let's start off with 0 and do the positives, and then we'll do the negatives, okay? So for the first one, when x equals 0, y is equal to 2 to the power of 0. On your calculator, it'll equal 1, but we know 2 to the power of 0 is already 1 without a calculator, okay? Right, so at 0, we get 1, all right? So if we place that point at 0, we get 1 on our graph, okay? Now, when we put in x equals 1, we get y equals 2 to the power of 1, which is just 2. So now we get 2. So at 1, we get 2. We place a dot. Okay, just moving that up ever so slightly so I don't block your view of the graph. At x equals 2, y equals 2 to the power of 2, which is equal to 4. And then you might notice a little bit of a pattern. We're doubling as we go along. Okay, you can make the prediction that this would be 8. And when I put in x equals 3, we get y equals 2 cubed, which is equal to 8. Now let's have a look at the negatives. Okay, all right, we'll just plot those values that we've just done. So at 2, we get 4. You'll notice that the y values are now jumping quite significantly. At 3, we get 8, and we're starting to see that quite sharp growth curve happening. So now going the opposite way, we'll do the negatives. Okay, we'll do those in purple. When x equals -1, plugging that into your calculator, 2 to the -1, you'll end up with 0.5. Okay. All right. So that's all fine and dandy, 0.5. On our graph here, okay, we're just going to put a dot at roughly the halfway mark. We're just sketching to establish a pattern here. Same thing with x equals -2, y is equal to 2 to the -2, which is equal to 1/4 or 0.25. So placing that value slightly smaller, and this is why I'm not going to do much more than this. When I go and graph my curve, noticing that I'm on an iPad, so I will do my absolute best here to create a lovely graph for you as best as I can. Okay. All right, we have our curve doing that behavior. Okay, so some things that we want to note. It's looking like we're going to approach this x-axis here, but we're not going to quite ever touch it. Okay, for example, if I go and put in -100, it's just going to be a really, really small fraction, but my number will be still positive. So we say that this is an asymptote, right? So that is where our curve will approach, but not touch. And that's a feature of an exponential curve. And this happens here at y equals 0, okay, the horizontal line. The other thing that you might notice, okay, is that for the basic curve, we go through with a y-intercept of 1. So when x is 0, y is 1, okay? Okay, so that's the basic version of sketching an exponential. Now we might change it up and see how it behaves when we go to a negative in the power, okay? I'll probably do a little bit less working here, but I will show how it works. Keeping in mind that you can see that we're multiplying up here by 2 each time. And when we go this way, we're still technically going up by a factor of 2 if I was to go that way, but we're dividing in the opposite direction. So let's have a little bit of a look here at y equals 2 to the minus x for our next one. Okay. Alrighty. So our rule here is going to be y equals 2 to the power of minus x. And I did talk a little bit about this earlier. We know this is going to be a decay curve. Okay. Same thing's going to happen. You might notice a little bit of a pattern occurring that was similar to our last curve. So let's have a little bit of a look. Okay. All right. So creating a table of values here, we have x, we have y. I'm going to do the same things, and I'm just going to highlight to you a little bit of a pattern. -2, -1, okay, 0, 1, 2, and 3. I'm going to keep my answers here as fractions, just so I can highlight what's basically going on. You'll see a little bit of a pattern in terms of what occurs. So this one, being really, really careful because we have a negative in the power, I'm going to start from the negatives and I'll just show you what happens. So when x equals -2, y is equal to 2 to the -2. Noticing here that those two negatives, cannot stress that enough, will become a positive. So plugging that into your calculator, this is why it's really, really important to have that in a bracket so you don't make that mistake. Plugging that into your calculator, you'll get 4. Interesting. So here at -2, we go up to 4. Remember, we said this is a decay curve, so we're expecting for x equals -1 to be a little bit lower. Okay, so for x equals -1, y is equal to 2 to the power of -1, which is equal to 2. So our y value has gotten lower. So at -1, we go to 2. It's looking fairly similar to our other curve, but going in the reverse direction. You can probably start to make some projections here, but let's just check. We'll do two more. When x equals 0, y is equal to 2 to the power of -0, which is equal to 1. Okay. Okay, so we're going through the same point on the y-axis. And when x equals 1, y is equal to 2 to the -1. There's nothing changing there. You plug that into your calculator, you'll end up with 0.5 or a half. Now, you might notice a little bit of a pattern here. What ends up happening is now we're going down by a factor of 2. Okay, so we can make a prediction. I'm going to find half of 0.5, which will be a quarter. Half of that will then be 1/8. That looks fairly similar to what was happening above on our other curve, just going in the opposite direction. For example, we are increasing in that direction. Okay, as you can see, we have 8 here at x equals 3. But when x equals 3 here, we actually have 1 divided by 8. And that's why we have a decay curve. So how do we go and identify those? Well, we'll have a look at that just after we finish sketching it. Okay, putting in 1, we get a half. Putting in 2, we get a quarter, and so forth. And now we're going to sketch this. So noticing at -3 will end up at an eighth. Sorry, 8. My apologies. Okay, putting all of this together. Okay. Again, you're going to have that asymptotic behavior, right? That asymptote going across there. And I'd encourage you with a different colored pen when you're sketching these to include that asymptote so you can remember, okay? All right. So same thing is occurring. We go through the same y value. We just need to be really, really careful with how that's working, okay? All right. So in our next video, I'm going to show you how to go and sketch a slightly harder version of an exponential function and how to identify which one is growth, which one is decay, and give you a general summary of what's happening. Okay?